Working on page 3 of, excuse me, chapter 4 practice test. We had started it in the last video and ran out of time, so I'm just going to start from scratch here. So most missed problem on the test, right here. This one, and then there's one on front. They were missed the most. The reason this one was missed so much is because students see the cubes and think they're cubes right from the beginning, but 3 is not a cube. Nothing times itself 3 times gives me 3. Nothing times itself 3 times gives me 24. But that should be your hint. Well, it looks like a cube, but it's not quite right. And then you go, oh, look, there's 3 common. So you take a 3 out as a GCF. This is another one of the 8 that is 2 steps. And you get x cubed plus 8y cubed. Now it is a cube because x times x times x is x cubed. 2 times 2 times 2. Boy, I'm too many videos today. Let me take a quick drink. Okay, 2 times 2 times 2 is 8. Y times y times y is y cubed. So now it is cubes. So with cubes, we learn SOAP. SOAP means same sign as the original problem, opposite sign of the original problem, always positive. And remember, cubes are the only one that has a little parenthesis and a big parenthesis, and they also can never be factored again if you've taken the GCF out at the beginning. So that's why I went straight down to the answer line, because they won't be able to be factored again. So we learned with cubes, you take the cube root, and that's how you get the first parenthesis. And this is the most important step of the whole problem, because if you miss the first parenthesis, that makes you miss all this, because you use the first parenthesis to fill this in. So cube root of x cubed, that means what number times itself 3 times gives me x cubed. X, cube root of 8 is 2. Cube root of y cubed is y. 2 times 2 times 2, 8. Y times y times y, y cubed. Then we had another acronym for this one, and it was square, multiply, square, or just SMS, if you remember the letters. And so that means I square the first term, x times x, because we just go left to right. So that's x squared. For the multiplication, we multiply the 2 terms, x times 2y. So that's 2xy. So number goes first, then letters, alphabetical order. Then we square the last term, which is 2y times 2y. And do you know how many people write 2y squared for that? Or they write 4y? Don't rush on that. It's 4y squared. And that would be my answer. So 2 types of factoring. The first type was GCF. Then we had cubes. So 2 factoring patterns. GCF first, and then once you took the GCF out, then you recognized, oh, now it is cubes. Number 15 is another 2-stepper. So I think this is our 5th one, 6th one. That's 2 steps. So we look at that and I go, whoa, those are some big numbers. Well, that should send off the antenna. Whoa, big numbers. What'd she tell us to do? Oh, look for a GCF. Big numbers and weird exponents usually mean a GCF. And there is 7 common, because 3 and 7 go into this, and I can see these are all divisible by 7. So when I take 7 out, I see I'm left with 3x squared minus 11x plus 10. And remember, if your polynomial has an exponent or something common, that means you can probably keep going. So how do you know if it keeps going? Because students always say, how do you know if it keeps going? Well, multiply your A and C, because this is an AC method if it does keep going, because there's not a 1 in front. And then you just ask yourself, are there factors of 30 that add to 11? If you can't find any, then it doesn't factor again. If you can find some, then it factors again. And don't we have 5 and 6 adding to 11? So that means it can factor again. So factors of 30, reading the problem backwards, that add to 11, 6 and 5. Now we have to do the signs. This says they'll both be the same. And this says they're both going to be negative. So is negative 5 plus negative 6 negative 11? Yes. So now I'm going to take this out and replace it with those two. And remember, you have to use the same variable, so they're both going to have x. So if you want, you can go down there. Remember how I showed you to do this on page 2 so you don't lose that 7? Put it out in front, and now we can do our stretch it out into 4 terms and get it ready for grouping. So 3x squared stays the same. This time I can't make my negative go first because they're both negative. So I'm going to put the 6 with the 3 and the 5 with the 10. So I'm going to write negative 6x, negative 5x, positive 10. And if you didn't recognize that, doesn't matter. Order doesn't matter. Negative 5x plus negative 6x is still negative 11x. So it does not matter, the order. I just saw these had something in common and then these would. So then once we get it stretched out into 4 terms, then we do grouping. So GCF here would be 3x. When I divide both of these by 3x, I get 1x to the first, or just x, minus, here the x's cancel, 2. Oh, gee, wow. Did you guys just see what I did? I did it again. Wrote it in the answer blank. Yikes. Okay, next we have a negative. So that means our next GCF is going to be negative 5, not just 5, negative 5, because we always have to take the negative out if it's the leading coefficient. So that leaves us with positive 1x and negative 2. And our 7's already there, so we can cross it out. We can see x minus 2 is common, which there has to be a common binomial or you've made a mistake. So I take that out, and then what's left goes in the second parentheses. So that's our, I think, 5th one that has had 2 factoring patterns. So it had GCF, and then it had AC method. So GCF and AC. So you can write that up here. GCF was first, then we did AC. And GCF is always first. So that should never be done anywhere else but at the beginning. Okay, 16. We did 3 of these in our notes. And this is one of those that I told you we're going to have on 3 different tests. It's on this test, then we have it again on the Chapter 7 test, then we have it again on the final exam. Because this is a huge concept in calculus. It's called U substitution. So it doesn't look like our normal problem, x squared plus 9x plus 14, but it's in that form. So that tells us, oh, when there's a repeated quantity like that, we call that U. So U is going to be x plus 3. Because we usually don't have parentheses and repeated quantities, so those parentheses should tell you it's a U substitution. So whatever is the common element, call that U. And you might even want to highlight it just so you remember at the end to plug it back in. And these are not hard. You just have to practice a couple and they get pretty easy. So everywhere you see x plus 3, replace it with U. So I see x plus 3, so I write U squared plus 9U plus 14. And now it's just a regular, yay, double bubble. We can go right to the answer, except then we got to do that. So all positive signs, so that means these are positive. Factors of 14 that add to 9 are 2 and 7. And there we go, all factored, but we're not done. This problem has x's. We can't give an answer with u's. So this is our hint. Oh yeah, we got to put the x plus 3 back in. That's why we highlighted it to remind us. So then put the x plus 3 back in. So you take it out just so you can work the problem and it looks normal. Then we put it back in. So our first parenthesis is going to be x plus 3 plus 2. Our second parenthesis is going to be x plus 3 plus 7. Combine like terms and you are done. So 3 plus 2, 5. 3 plus 7, 10. Boom, finished. So see, use substitution, not hard at all. You recognize it by the parentheses. That's a real common characteristic. Later on, we'll have radicals in it and negative exponents, so that's ways to recognize it. But in this chapter, it's usually the parentheses that tell you it's use substitution. This one is the one I told you in our notes, very hard to check because you would have to FOIL that, distribute that, combine like terms, and then factor that and see if you get this. So yeah, it's a little bit hard. So 17 is two terms. So remember what we learned about two terms. It can either be GCF, that's what we check first, squares, or cubes. So any GCF? No. So that's off the list. Squares? So students go, yes, it's squares. But remember, it's called a difference of squares. This is not a difference of squares. We don't know how to factor a sum of squares. So this is called a difference of squares. That is not a difference. So who remembers what we wrote in our notes for the plus ones? Prime. And it's not cubes because the exponents aren't divisible by 3. So we just write prime. And the reason we only know how to factor squares if they're subtraction. So if it's plus, and you can go back and look at your notes, your 8.7 notes, if it's plus, we don't know how to factor it. So I will put 1, everybody listening, 1 prime on the test. So don't write prime 53,000 times. There's 1 prime on the test. And the reason it's prime is because it's a plus sign. Okay, I think we have time to do one more, and then we'll have to start a new video. So that x to the 4th is really drawing my attention on this one. I'm going, ooh, wow, look at that. But unlike the last x to the 4th one we did, there's nothing common here. So we learned about these in the 2-7 notes too. They're called quadratic in form. So what that means is factor them like you would a quadratic. Oh, yay, leading term positive. 1. When it's positive 1, that means I can go right to the answer. No AC method, no GCF, go right to the answer. So when it's x squared, we write x and x. So when it's x to the 4th, the only difference is we write x squared and x squared. It's the only difference between that and the others. So this says the signs will be the same. This says they'll both be negative. So x squared minus, factors of 30 that add to 13 are 3 and 10. I see exponents, so that tells us it possibly could factor again. Is this a difference of squares? Difference, square, not a square. Difference, square, not a square. So guess what that means? That is our answer. So that's one of the few times we'll have exponents, but it won't match any of our factoring patterns. It's not squares, it's not cubes, no GCF, so we're done.